Welcome to G Fun Facts Online. Imagine an operating room. The only sound is the rhythmic beep of a heart monitor. A patient's life is on the line, their own heart is failing. The surgical team is focused, but this isn't just any transplant. The new heart, ready to beat inside a human chest, didn't come from a human donor. It came from a pig. This isn't science fiction. This is the world of xenotransplantation, a revolutionary and controversial field that could solve the global organ shortage crisis once and for all. For decades, the idea was a dream. Early attempts failed miserably as the human immune system violently rejected animal tissue. But now, with advanced gene editing tools like CRISPR and a much deeper understanding of our own biology, that dream is becoming a clinical reality. We've seen the first successful transplant of a genetically modified pig heart into a living person, and even a combined heart pump and pig kidney transplant. These breakthroughs are offering real hope to the hundreds of thousands of people waiting for a second chance at life. Today, we're diving deep into the intricate science, the challenging history, and the profound ethical questions of xenotransplantation. So why are we going to such incredible lengths? The answer is simple and desperate: the global organ shortage. In the United States alone, more than 100,000 people are on the national transplant waiting list. A new name is added to that list every 9 minutes. And every single day, 17 of those people die waiting. This huge gap between the demand for organs and the available supply is the primary engine driving scientists to find alternatives. While we've gotten better at using organs from older donors and have developed machines that can keep organs preserved for longer, it's not enough. The waiting lists just keep getting longer. Xenotransplantation could be the answer, offering the potential for an almost unlimited supply of life-saving organs. But this journey has been a long and winding road. The idea of using animal parts in humans isn't new at all. One of the earliest documented attempts was back in the 17th century, when a physician named Jean-Baptiste Denis tried transfusing lamb's blood into a human. As you can probably guess, it didn't go well. In the 19th century, surgeons experimented with skin grafts from pigs, sheep, and even frogs to treat burn victims. But without understanding the immune system, these were shots in the dark. The 20th century brought a more scientific approach. The invention of techniques to reconnect blood vessels was a critical step, earning a Nobel Prize in 1912 and laying the foundation for modern transplants. But early attempts to transplant organs from pigs and goats into humans still failed, with patients surviving for only a few days at most. The first real breakthrough came in the 1960s with the discovery of immunosuppressive drugs. These were medicines that could dial down the body's natural tendency to attack foreign tissue. This sparked a new wave of interest. In the 60s, surgeons transplanted baboon kidneys into 6 patients who survived between 19 and 98 days. In another series of transplants, chimpanzee kidneys were used, and one patient lived for 9 incredible months. Then came the story that captured the world's attention, the case of baby Faye in 1984. Born with a fatal heart defect, this infant received a heart from a baboon and survived for 21 days. While the procedure wasn't a long-term success, it ignited a global debate about the ethics and the very possibility of cross-species transplants. By the 1990s, scientists began to shift their focus away from primates and toward pigs. Pigs have several key advantages. Their organs are remarkably similar in size to ours. They are much easier to breed in large numbers, and they grow to maturity much faster than a primate. But one massive hurdle remained: the human immune system. Our immune system is an incredibly effective security force. Its job is to identify and destroy anything that it doesn't recognize as self. When a pig organ is introduced, the immune system launches an all-out assault, and this attack comes in waves. The first and most violent wave is called hyperacute rejection. It happens within minutes. Our blood contains pre-existing antibodies that instantly recognize a specific sugar molecule on the surface of pig cells called alpha-gal. Humans don't have this sugar, so our bodies see it as a massive red flag. These antibodies trigger a catastrophic chain reaction that completely destroys the new organ. For decades, this was the insurmountable wall. But now, using the revolutionary gene editing tool CRISPR, scientists can go into a pig's DNA and simply delete the gene responsible for making the alpha-gal sugar. It's like removing the red flag from the enemy's uniform. This single change was the key that unlocked the door to modern xenotransplantation. But even if you avoid that initial hyperacute rejection, the fight isn't over. In the days and weeks that follow, the immune system launches secondary attacks. This is called acute rejection, and it involves both antibodies and specialized killer T cells that systematically hunt down and attack the foreign pig cells. To counter this, scientists are now making dozens of genetic modifications to the donor pigs. Recent successful transplants have used organs from pigs with as many as 69 genetic edits. These edits do two main things. First, they add human genes into the pig's DNA. This essentially humanizes the organ, making it fly under the radar of our immune system. These human genes can do things like regulate our immune response and prevent the dangerous blood clots that can form in the transplanted organ. Second, other edits knock out more pig genes that are known to trigger an immune response. It's an incredibly complex process of genetic engineering, creating a designer organ that is part pig, part human, and tailor-made to survive in a human body. Alongside these genetic marvels, the patients themselves must take a cocktail of powerful immunosuppressive drugs to keep their body's defenses at bay. Then there's another major concern: the threat of zoonosis. This is the risk of transmitting diseases from animals to humans. A big worry is something called porcine endogenous retroviruses, or PERV. These are ancient viral DNA sequences that are literally embedded in the pig's genome. While there's been no evidence so far of these PERVs being transmitted to human patients in trials, the risk is still there. Scientists are tackling this by carefully screening and selecting donor pigs that are free of the most dangerous PERV subtypes, and they're even using CRISPR to inactivate PERV genes directly in the pig's DNA, adding another layer of safety. As you can imagine, this groundbreaking science pushes us into a complex ethical maze. There are no easy answers here. First and foremost is the issue of animal welfare. The pigs used for these procedures aren't ordinary farm animals. They are genetically engineered and then raised in completely sterile, pathogen-free environments. This often means they are born via C-section and live in isolation to prevent any chance of infection. This prevents them from expressing natural behaviors. Are the genetic modifications themselves causing the animals to suffer in ways we don't yet understand? Ethicists argue that if we are to proceed, we have a profound moral obligation to provide the highest possible standard of care and to minimize any pain or suffering for these animals. Then there's the question of patient safety. The first people to receive these organs are true pioneers, stepping into completely uncharted medical territory. The long-term effects are unknown. There's the risk of rejection and the risk of a new zoonotic disease emerging. Patients must be made fully aware of all these risks. And there's a unique challenge. These patients may need to be monitored for life for any signs of infection, which raises questions about a patient's right to withdraw from a research study. What happens if they no longer want to be monitored? And of course, different cultures and religions have very different views. In many Western societies, it's seen as a pragmatic, scientific solution to a medical crisis. But some Eastern cultures with Buddhist or Shinto beliefs about the sanctity of all life may have serious reservations. Some Islamic and Jewish traditions prohibit the consumption of pork, which can influence attitudes, although many religious scholars argue that using a pig organ to save a human life would be permissible. Open and honest public discussion is absolutely critical to build trust and navigate this new landscape. Beyond the ethics, there is the economic equation. The research and development are incredibly expensive right now, but if xenotransplantation becomes a routine procedure, it could actually be far more cost-effective than long-term treatments like dialysis. One study estimated that a successful kidney transplant could save the U.S. healthcare system around $146,000 per patient per year. Patients who get a new organ can often return to work and lead productive lives, which has a broader economic benefit for everyone. Behind all the science, ethics, and economics are the very real, very human stories of the patients. In 2022, David Bennett became the first person to receive a genetically modified pig heart. He survived for 2 months. While his death showed that there are still major challenges to overcome, his incredible courage provided priceless information for the entire medical community. In March of 2024, Richard "Rick" Slayman was the first to receive a genetically modified pig kidney. He also passed away about 2 months later, though his doctor stated they did not believe his death was a result of the transplant itself. His family said they hoped his story would inspire hope for other patients on waiting lists. And more recently, in late 2024, a woman named Tawana Looney became the third person to receive a gene-edited pig kidney. As of early 2025, she is the longest living person with a pig kidney transplant, a powerful symbol of the progress being made. These stories, both the setbacks and the successes, are what drive this field forward. Given how new and complex this all is, strong regulation is essential. Global bodies like the World Health Organization and national agencies like the U.S. Food and Drug Administration, or FDA, have set up strict guidelines. These rules cover everything from how the animals are raised to how clinical trials are designed. Ensuring patient safety and ethical conduct are the top priorities. In a massive milestone for the field, the FDA gave the green light in early 2025 for the first formal clinical trials of pig kidney transplants in humans. These trials will provide the crucial data needed to determine if this technology is truly safe and effective enough for wider use. Now, xenotransplantation isn't the only horse in this race. There are other incredible technologies on the horizon. One of the most exciting is 3D bioprinting. The idea here is to use a patient's own cells as a kind of bio-ink in a specialized 3D printer to build a brand new organ from scratch. This would completely eliminate the risk of immune rejection, but the technology is still in its very early stages. Scientists are also looking at stem cells to repair damaged organs or even grow new ones. But just like bioprinting, this is likely many years, if not decades, away from being a common treatment. Right now, xenotransplantation is the most clinically advanced and realistic solution to the organ shortage we have. The journey has been long, filled with both triumph and tragedy. It is a field that forces us to ask deep questions about our relationship with other animals, the limits of science, and the value of a human life. As the first official clinical trials begin, the world is watching. The hope is that this new dawn of transplantation will finally bring the gift of life to the thousands of people waiting for a second chance.